Now we're about to solve equations with rational exponents, that is, fractional exponents. And we're going to be using the same power property that we used when we solved radical equations. To solve an equation with rational exponents, we'll raise both sides to the reciprocal power so that the exponent will become a 1. You see, we're using the same power property that we used when we solved radical equations. But here's the catch. If you raise both sides of an equation to a power with an even denominator, you're essentially taking the square root of both sides, and you must insert the plus minus symbol. You catch that? If you raise both sides of an equation to a power that has an even denominator, it's like you're taking an even root of both sides. And remember, when we take the square root of both sides, we have to insert the plus minus symbol, and you need to check your solutions. Also, if you raise both sides to an even power, you need to check your solutions. So here's a pretty simple looking equation. We've got x to the 3/5 power equals 27. So what we want to do to eliminate this 3/5 exponent is raise both sides to the 5/3 power. Now 3/5 times 5/3 is 1, so the left side is just x. And now the right side is the third root of 27 to the 5th power. Okay, I wrote the power outside because it's easy to do the third root of 27, and of course the 5th power of 27 would be a giant number. So let's do the root first. The third root of 27 is 3, and then it's easy to do 3 to the 5th. That's just 243. Now we need to check, so we're going to make sure that 243 to the 3/5 really is 27. So the 5th root of 243 is 3, and then 3 to the 3rd power is 27, so that one checks. Now let's look at x minus 4 to the 2/3 equals 16. So of course, to eliminate the 2/3 exponent, we'll need to raise both sides to the 3/2 power. But now notice that even though my top number is odd, my bottom number is even, which means that essentially we're taking the square root of both sides here. So whenever we take the square root of both sides, we have to insert our plus minus symbol. And now these powers multiply together and become 1. So the left side is x minus 4. The right side is plus or minus 16 to the 3/2. So what I would do, I guess, is let's write this in radical form. Square root of 16 to the 3rd power. And again, we put the power outside because it's easier to do the root than it is the power. So the square root of 16 is going to be 4. And then the 3rd power of 4 is 64. So we have x minus 4 equals plus or minus 64. So we're going to get two answers here. Adding 4 to both sides, x equals 4 plus or minus 64. So if we do 4 plus 64, we'll get 68. If we do 4 minus 64, we'll get negative 60. And those two solutions must be checked. So I'm just putting the 68 in place of my x. 68 minus 4 is 64. 64 to the 2/3 is the cube root of 64, and then we square it. Notice, the bottom of the exponent becomes the index, and the top of the exponent is the power. So the cube root of 64 is 4, and 4 squared is 16, and that is a match for the right side. So 68 is a good solution. And let's do the same thing with negative 60. If we put negative 60 in place, negative 60 minus 4 is going to give us negative 64. And the cube root of negative 64 is negative 4. And negative 4 squared is also 16. So that's a match. And so we got two solutions here, both 68 and negative 60. Now here, of course, is one for you to practice on. We've got x to the 3/2 equals 125. So your goal is to eliminate the 3/2 exponent. You're going to raise both sides to the 2/3 power. And then the left side exponents cancel out. We get x. On the right side, we'll need to evaluate this exponent. So we're doing the cube root of 125, and then we're going to square that answer. The cube root of 125 is 5, and 5 squared is 25. So our proposed solution is 25. We need to check it. So 25 to the 3/2 power, we're going to be doing square root of 25, and then cubing that answer. And the square root of 25 is 5, and 5 to the 3rd is 125, which is a match for our right side. So that solution is good. Now here's another problem for you to try on your own. So pause the video and give it a try. And if you've had a chance to do that, now let's go through it together. Okay, so we have x minus 3 to the 2/5 equals 4. We'll need to eliminate this exponent. So we'll raise both sides to the 5/2 power. Now because the denominator we're raising both sides to, the denominator of the exponent, is even, we're essentially taking the square root of both sides, so we'll insert the plus minus symbol. And over here on the left, these two exponents multiply together and make 1. So we have x minus 3 to the 1st power, which is just x minus 3. On the right, we have plus or minus 4 to the 5/2 power. Now the half power represents the square root. And then the 5 represents 5th power. So we've got plus or minus the square root of 4 to the 5th power. And the square root of 4 is 2. And then 2 to the 5th is 32. And now we're going to add 3 to both sides. We have x equals 3 plus or minus 32. Now 3 plus 32 would be 35, and 3 minus 32 will be negative 29. So those are our two proposed solutions. We need to check them both. If we check 35, 35 minus 3 is 32. 32 to the 2/5 powers, well, first we'll do the 5th root, and then we'll do the 2nd power. So the 5th root of 32 is 2, and 2 squared is 4, which is a match for the right side. So that solution checks out. And now let's check the negative 29. Negative 29 minus 3 is negative 32, and negative 32 5th root is negative 2, and then negative 2 squared is 4. And so that one checks out. And so our two solutions are 32 and negative 29. Next, we're going to look at equations that are quadratic in form. Now, an equation is said to be quadratic in form if it can be written as au squared plus bu plus c equals 0. In other words, we can make it look like a quadratic by doing a substitution. The big thing to look out for on quadratic in form equations is that the power on the leading term will be twice as much as the power on the middle term. So always look for that relationship for this exponent to be twice as much as this one. Now here's our first example of an equation in quadratic form. And notice that the exponent on the leading term is twice as much as the exponent on the middle term. And that is your clue that you have an equation that's quadratic in form. And then you can use the method I'm about to show you. Alright, so what I always do first is look for the coefficients. Now you don't see coefficients here, so you just know that those coefficients are 1. And now, where the variable would normally go for the middle term, let that expression equal u. And now u squared is going to be that quantity raised to the 2nd power, which would be this leading variable term. And so we can have 1u squared minus 1u minus 2 equals 0. And so that's what I have here. Now this is quadratic and can be factored. U squared will be u times u. The signs need to be different. And last times last is 2. I'm going to put my 2 here so that the middle term will add up to negative 1u. And now we will get two solutions from this. U plus 1 equals 0 gives us u equals negative 1. And u minus 2 equals 0 gives us u equals 2. But those are not the final answers because these are values of u, and we're supposed to be solving an equation with x's. So we need to plug these u values into our substitution that we made up. So we'll get, when we substitute the negative 1, we'll get negative 1 equals x plus 1 to the 1/3. Now to get rid of the 1/3 power, just like we did on the last set of equations, we will raise both sides to the reciprocal power, which is 3. And negative 1 to the 3rd power is negative 1. And on the right side, these two exponents cancel out and make a 1. So we just get x plus 1. Now subtract 1 from both sides, and we'll have x equals negative 2. That's one of our solutions. And now we do the same thing with the 2. And we cube both sides, and we get 8 equals x plus 1. Subtract 1 from both sides now, and x equals 7. So our two solutions are negative 2 and 7. And let's go ahead and check both of those solutions. So putting the negative 2 in place of the x, I'm going to get negative 2 plus 1, which is negative 1, in both parentheses. Okay, now negative 1 to the 2/3 power, what you do is you take the cube root and then square it. So the cube root of negative 1 is negative 1, and then negative 1 squared is positive 1. And then it's going to be minus, third root of negative 1 is negative 1. And then we have our minus 2 equals 0. So let's see if this is going to check now. 1 plus 1 is 2, and 2 minus 2 is 0, so that does check. Okay, now checking the 7. We'll put 7 in place of the x. So inside the parentheses, 7 plus 1 is 8. We'll have 8 to the 2/3 minus 8 to the 1/3 minus 2 equals 0. Now, the cube root of 8 is 2, and 2 squared is 4. And here the cube root of 8 is 2, and then 2 to the first is 2, minus 2. Okay, this is going to check as well because 4 minus 2 is 2, and 2 minus 2 is 0, and that's what we wanted. And so that checks, and our two solutions are negative 2 and 7. Now here's another example. This is part B of example 8, and this one is not really quite as complicated as the last one we looked at. It says 6x to the negative 2 plus x to the negative 1 equals 2. And we can solve this one using that same substitution method that we saw before, because this exponent is twice as big as this exponent. Now remember, I told you to look for the coefficients, and so the coefficient of this middle term would be 1, and what we would want to substitute the u in place of is this expression. So where the variable would normally go on a quadratic equation, for the middle term of the quadratic equation. So I say let's let u equal x to the negative 1, and then u squared will be x to the negative 2. So we can have 6u squared plus 1u equals 2, and that's a quadratic equation that we can solve. So I've moved the 2 over to the left side so I can have a trinomial, and now let's try to factor this trinomial. 6u squared can be factored into 3u times 2u. The signs need to be different, so I'm going to put a plus and a minus here. I'm going to start out putting the plus here, and then if I need to change it, I'll know later. Alright, 2 has to be 2 times 1. I know the 2 can't go here because that would create a common factor, and I know that I'm not supposed to have a common factor. So let me put the 2 here. And now let's see if our signs add up the way we want them to. Outer times outer is negative 3u. Inner times inner is positive 4u. Negative 3 plus 4 does add up to positive 1. That's what we wanted. So this factoring is right. Now we're going to get two u solutions from this factoring. If 3u plus 2 equals 0, then u is negative 2/3, and if 2u minus 1 is 0, then u is 1/2. And now we need to take these u solutions and put them back in terms of x. So remember, u is x to the negative 1. So I can take this u expression and put it in this x, u equals x to the negative 1. And now, what does negative 1 mean? It just means reciprocal. So I'll raise both sides to the negative 1 power. That'll give me a positive 1 on the right, but the reciprocal of negative 2/3 is negative 3/2. Remember that when you do a reciprocal, the sign does not change. A lot of people think the sign changes. It does not. So if it was negative before, it'll still be negative after. So this is one of our x solutions. And now let's take the 1/2, do the same thing, raise both sides to the negative 1 power. That just accomplishes a reciprocal for us, and we have x equals 2. And so our two solutions are 2 and negative 3/2. Now we should check, so what I'm doing here is I'm going to plug the negative 3/2 into our original equation. Alright, negative 3/2 to the negative 2 power, it's going to flip it over and it's going to square. So when you flip this over and square it, you get 4/9. And when you flip this over, you get 2/3. It was negative, so I've just put my minus sign here, and that's supposed to equal 2. Let's see. 6 times 4/9 would simplify to 2 times 4/3. That's going to be 8/3 minus 2/3, which is 6/3, and we know that 6/3 is equal to 2, which is our right side, so that checks. That looks good. Now let's check the 2. So we'll put 2 in place of the x. That's going to give us 6 times 2 to the negative 2 plus 2 to the negative 1 equals 2. The 2 to the negative 2 is going to become 1/4 because when you square the 2 you get 4, and then the negative exponent makes us flip it over. So that's 1/4. 6 times 1/4 gives us 6/4 plus 2 to the negative 1 gives us 1/2. And now we need a common denominator to add these two together. 1/2 becomes 2/4. So we have 6/4 plus 2/4, that's 8/4, which reduces to 2, which is what we wanted the right side to be. And so that solution checks. And our two solutions are negative 3/2 and positive 2. Okay, here's a good problem for you to use as a try it yourself problem. So pause the video and try this one on your own, and then I'll go through it with you. If you've had a chance to do that, now let's work this together. So I see that our exponent here is twice as much as our exponent here. That tells me this is quadratic in form. I also see that we have a coefficient here, and that tells me that I want this expression to be my substitution. So I'm going to let u equal x plus 1 to the 1/5 power. And then u squared, of course, would be x plus 1 to the 2/5 power. Now let's put our substitution in place. It's going to be 1u squared minus 3u plus 2 equals 0. This is a factorable expression, so let's factor this into two binomials. U squared is going to be u times u, and the signs both need to be the same, and they're both going to have to be minus. And in order to get the 2, we're going to need a 2 and a 1. So you probably can tell what solutions we're going to get for u. U minus 2 equals 0 means that u equals 2, and u minus 1 equals 0 means that u equals 1. So remember, these are not the final answers. These are just the intermediate answers that we got. These are u. We are supposed to be finding x. So now I have to take my u answer and put it back in this expression. So if we do the 2 first, that's going to make 2 equals x plus 1 to the 1/5. And now I have to solve for x. So we'll raise both sides to the 5th power. And on the left side, that's going to give us 32. And on the right side, x plus 1, just subtract 1 from both sides, we get x equals 31. And for the 1, put 1 in place of the u. So 1 equals x plus 1 to the 1/5 power, raise both sides to the 5th power, and we get 1 equals x plus 1. Subtract 1 from both sides, and we get x equals 0. So these are our two proposed solutions. Now we'll check them. If we put 31 in the parentheses, then each parentheses will be 32. So we'll have 32 to the 2/5 minus 3 times 32 to the 1/5 plus 2 equals 0. All right, let's evaluate this. The 5th root of 32 is 2, and 2 squared is 4. So we're going to have 4. And here the 5th root of 32 is 2, and 3 times 2 is going to be 6. So we have 4 minus 6 plus 2. That does add up to 0, which is what the right side was supposed to equal, so that checks. And now let's try the 0. If you put 0 in here, 0 plus 1 is 1. Okay, now, of course, 1 to the 2/5 power is still 1. And 1 to the 1/5 power is still 1. So I have 1 minus 3 plus 2, and that's going to add up to 0, which is what we needed it to. So the 0 checks, and our two solutions are 31 and 0. And here is another try-it-yourself problem that you can pause the video and work on your own. And if you've had a chance to try it by yourself, let's go through it together. So we see that we have this exponent is twice as much as this one. And we also see that we have a coefficient here. So let's let this be our u substitution. We'll let u equal x to the negative 1. And that way, this will be u squared, and this will be u, and we'll have 10u squared plus 33u minus 7 equals 0. Now this is factorable, so let's break it down into two binomials. 10u squared can be 5u times 2u. The signs need to be different. And last times last needs to be 7. So let's put the 7 here and the 1 here. And that way our middle term will be 35u minus 2u, which adds up to 33u, which is what we wanted. So this factoring is good. Now we can set each of these equal to 0 and get our u solutions. So if 5u minus 1 equals 0, we'll get solutions. And then we'll get solutions for 2u plus 7. Let's solve this one. So 5u equals 1 and u equals 1/5. And then let's solve this one. 2u is negative 7 and u is negative 7 over 2. So these are our two u solutions. We need to stick each of these into our u substitution and find x. So if 1/5 is equal to x to the negative 1, we'll raise both sides to the negative 1, which will give us 5 equals x. And if negative 7/2 is x to the negative 1, then we'll raise both sides to the negative 1, and we'll find out x equals negative 2 over 7. So these are our proposed solutions, and we need to check them both. Checking the 5 in the original equation, we're going to get 10 times 5 to the negative second plus 33 times 5 to the negative 1 minus 7 equals 0. Well, 5 to the negative second will be 1 over 25, and 5 to the negative 1 will be 1 over 5, so we end up with this. You could just take a calculator and quickly verify that this adds up to 0, and it does. And now let's plug in the negative 2 over 7. And negative 2 over 7, when you square it and flip it, you're going to have 49 over 4. And then when we flip the negative 2 over 7, we're going to have negative 7 over 2. Okay, now also take a calculator and verify that this one adds up to 0, and it does as well. So our two solutions here are 5 and negative 2/7. One of the biggest mistakes people make on equations like this is they get their answer in terms of u, and they forget to do the last step and get their answer in terms of x. It's really important that you get your answer back in terms of the original variable. Now here's example 9. This one's really not any harder of a substitution than the last one we did together, but it does have a step at the end that maybe is a little different. So let's look at it together. Here we have x to the 4th and x squared. So we see that this is quadratic in form since this exponent is twice as much as this one. Let's let u equal x squared. And then we can write 12u squared minus 11u plus 2 equals 0. This is factorable, so we'll break that down into two binomials. 12u squared is 3u times 4u. The signs need to be the same, and they both need to be minus. And 2 can only be 2 times 1, but I know I can't put the 2 here because it would create a GCF. Let's put the 2 here, and that will be 2 times 1. And then we can say if this times this is 0, one of our factors has to be 0. We'll set each factor equal to 0 and solve. We'll come up with u equals 2/3 and u equals 1/4. But remember, these are the u answers, so we need to get our solution in terms of x. So we'll plug both of these back into our substitution. If u equals x squared, that means 2/3 equals x squared. So to isolate the x, we'll have to do the square root of both sides. And whenever you do the square root of both sides, you have to put that plus minus in place. So x equals the square root of 2/3. Now, this is the answer, but it's not in the best form. So what we can do is rationalize this by splitting this up into two separate radicals and then multiplying top and bottom by square root of 3. So we end up with plus or minus square root of 6/3. And let's do the same thing for 1/4. If 1/4 is x squared, then take the square root of both sides. Don't forget to insert your plus minus, and then x equals plus or minus square root of 1 over square root of 4. It just so happens this time both of these radicals can be simplified, so we end up with plus or minus 1/2. So we got 4 answers there. We got plus or minus square root of 6/3, and we got plus or minus 1/2. Now I did just want to show you that this u substitution we've been doing is just one way of solving these. You don't always have to use a u substitution. For example, on an equation like the last one we did, you actually could factor it the way it is. X to the 4th can be broken down as x squared times x squared, and that will give us the middle term we want. So I'm just going to factor this one the way it is. 4x squared times 3x squared is 12x to the 4th. Make the signs the same, both negative. And then 2 is 2 times 1. We'll put the 2 here. And then outer plus inner is going to add up to a negative 11x squared. And so here we have two factors equal to 0. So just set each factor equal to 0 and solve. This 4x squared minus 1 is a difference of squares, which factors down to 2x minus 1 times 2x plus 1. We can get a solution from each factor. And this 3x squared minus 2 is a quadratic equation that's all set up for the square root property. Notice that we don't have an x term. So the easiest way to solve this type of quadratic equation is to move the constant to the right side, take the square root of both sides, and now because our entire right side is under a radical, let's break this radical up into two pieces again and rationalize just like we did before, and we'll still come up with plus or minus square root of 6/3, and our other two answers were positive 1/2 and negative 1/2. So we got the same 4 answers, just went about it a little different way. So the u substitution is a tool, and it's not like the only way to do that type of problem. Boy, this section was a lot of work. We did a lot of examples together, lots of different kinds of equations. We've had rational equations, radical equations, equations with rational exponents, and equations in quadratic form. And every single one of them has its own way that it needs to be approached. But I want to make sure that you think about what numbers cannot be allowed as solutions. On the rational equations, we were not able to accept answers that make a denominator equal 0. On the radical equations, we had to take any answers we got and make sure that they check in the original equation. And we did check on these others too, but it's mostly critical on the radical equations. So when you solve these in your quiz that you're going to take or on a proctored test, when you do these and you have to show your work, please make sure that you type the checking in on the radical equations, because that's part of the solving process. On the rational equations, you don't really have to go through the whole checking process. All you have to do is make sure that the solution doesn't cause the denominator to equal 0. But on the radical equations, it really is a part of the solving process, so please do show that when you show your work. So good luck with these. The key to doing well in this section is to give yourself plenty of time to practice, not all in one sitting, but to come and go, start and stop, so that it sticks with you. And think about what you're doing. Don't try to memorize steps, but really think about how each different type of equation works, and you'll find that the more you do it, the easier they get for you. Good luck.